This is just a video on some grade 9 vector questions that I'm assuming most people struggle with because they're pretty difficult. The last question that I'll be showing, you wouldn't ever get a question like that at GCSE. It's just a challenge question just to really target, those grade 9 students who are always getting full marks on their papers. So OABC is a parallelogram, OA is A and OC is C. X is the midpoint of the line AC, and OCD is a straight line such that OC/CD is k to 1. So we want to extend OC to a point D, and we want a line going from A to C where X is the midpoint. So we'll just draw that. And we know that X to D is 3C minus a half A. Okay, so we want to figure out what K is. So we want to find OC. Okay, well OC here is C, but we can't just say the answer is C, or just 1. Because we don't know what this is. It needs to be in proportion to this, okay? So if we can figure out what this full line is, then that's useful, because if we can figure out what the full line is, which we can do by going up here, down here, down here, then we can take away this small line, and we'll get CD. Okay, so this large line, take away the small one, is CD. Okay, so first of all, we need to go up here, and up here. Okay, so we can get from O to A, that's fine. So O to D will go this way, this way, this way. I've just written that here. O to A we know is A, but how do we get from A to X? Well, if X is the midpoint, then A to X is half of the line AC. Okay, and AC, well, we can figure out AC. Well, it's minus A plus C. Okay, so AX is minus A, AC is minus A plus C. So AX is half of that, which is minus a half A plus half C. Okay. So we've got O to A, we've got A to X, and X to D. We can figure that. Well, we don't have to figure because the question tells us it. So just plug this, that, into there, and this one into there as well, to get this, and simplify to get this. So OD is 7 over 2C. That means CD, we can figure it out by taking away OC. Okay? So 7 over 2C take away C is 5 over 2C, and that's CD. So the ratio is C to 5 over 2C from OC to CD. We can cancel the C's because they're in both. And we want a 1 on the right hand side. So we can times by 2 and then divide by 5. That means that K is 2 over 5. Okay, CDEF is a quadrilateral. Okay, and just this, you can read through that. I express FE in terms of E. Well, we can go this way and then this way. But we can't do that yet because we don't know any information about X. So the question tells us FC, where is that? FC is this way, so that's A minus B. We'll just put in the rest of this. So A minus B, A and B. Okay, so to get from F to E, we'll go this way, this way, this way. So A minus B plus A plus B. So that's 2A. And that's the first part done. M is the midpoint of DE, okay. X is the point on FM such that F to X, X to M is in the ratio N to 1. CXC is a straight line. Okay, so just put in this information. This is just a video on some grade 9 vector questions that I'm assuming most people struggle with because they're pretty difficult. The last question that I'll be showing, you wouldn't ever get a question like that at GCSE. It's just a challenge question just to really target, those grade 9 students who are always getting full marks on their papers. So OABC is a parallelogram, OA is A and OC is C. X is the midpoint of the line AC, and OCD is a straight line such that OC/CD is k to 1. So we want to extend OC to a point D, and we want a line going from A to C where X is the midpoint. So we'll just draw that. And we know that X to D is 3C minus a half A. Okay, so we want to figure out what K is. So we want to find OC. Okay, well OC here is C, but we can't just say the answer is C, or just 1. Because we don't know what this is. It needs to be in proportion to this, okay? So if we can figure out what this full line is, then that's useful, because if we can figure out what the full line is, which we can do by going up here, down here, down here, then we can take away this small line, and we'll get CD. Okay, so this large line, take away the small one, is CD. Okay, so first of all, we need to go up here, and up here. Okay, so we can get from O to A, that's fine. So O to D will go this way, this way, this way. I've just written that here. O to A we know is A, but how do we get from A to X? Well, if X is the midpoint, then A to X is half of the line AC. Okay, and AC, well, we can figure out AC. Well, it's minus A plus C. Okay, so AX is minus A, AC is minus A plus C. So AX is half of that, which is minus a half A plus half C. Okay, so we've got O to A, we've got A to X, and X to D. We can figure that. Well, we don't have to figure it because the question tells us it. So just plug this, that, into there, and this one into there as well. To get this, and simplify to get this. So OD is 7 over 2C. That means CD, we can figure it out by taking away OC. Okay? So 7 over 2C take away C is 5 over 2C. And that's CD. So the ratio is C to 5 over 2C. From OC to CD. We can cancel the C's, because they're in both. And we want a 1 on the right hand side. So we can times by 2 and then divide by 5. That means that K is 2 over 5. Okay, CDEF is a quadrilateral. Okay, and just this, you can read through that. I express FE in terms of well, we can go this way and then this way, but we can't do that yet because we don't know any information about X. So the question tells us FC. Where is that? FC is this way, so that's A minus B. I'll just put in the rest of this. So A minus B, A and B. Okay, so to get from F to E, we'll go this way, this way, this way. So A minus B plus A plus B. So that's 2A. And that's the first part done. M is the midpoint of DE. Okay. X is the point on FM such that F to X, X to M is in the ratio N to 1. CXC is a straight line. Okay, so just put in this information. C to X is a straight line. You can work this out because if M is the midpoint, we know that DE is B. That means from D to M is just going to be half of it because it's the midpoint. You only want to go half the actual distance, so it's half of B and then half of B. Okay, so yeah, okay. So what we don't want to do here, whenever you get a question like this, is you want to find two different ways to get from F to X. So one way is, well, we can just go this way, or we can go this way and this way. Okay, so we want to find two paths for F to X. So C to E, where's C to E? So C to E is A plus B, because it's minus A plus B, because it's the opposite direction, then plus 2A. Okay, and C to X, well, we can say that C to X is some amount of C to E. Okay, and I'll just explain that. So what this K represents is some fraction. So if we say, let's say we have this full line C to E, we don't know, well, we know what it is, it's A plus B, and say if we take say a third of it or 2/3 of it, we'll get C to X. Just like here, how we had D to E, a half of D to E is D to M. Similarly, some fraction of C to E will give us C to X. We'll call that fraction K, and we can solve for it later. Okay, and C to X is useful because now we can get from F to X, because we can go this way and then this way. So we'll just do that. We'll leave that there. So that's one way from F to X. Now another way is going just this way. Okay, so let's figure out what F to M is. So A minus B plus A plus half B. Okay, and simplify to get 2A minus half B. Now we can say again, well, F to X is just some fraction of this full line. We'll call that lambda. You can call this whatever you want, but it's just convention to use lambda and K, I think. So that's just what I've used. That we've called lambda. Over this full line, we'll get F to X. Okay, because these are both F to X, we can set them equal to each other, and then expand to get this. Now what we need to do is equate coefficients, and what that means is to have a look at the coefficients of A and B, or just like whatever these numbers that they've told us, whatever these letters are. So if it was a C, like in the other one, we'll look at C and whatever. So here, let's look at the coefficients. So what coefficients are just the numbers next to it. So for example, The coefficient of A here is 2 lambda. The coefficient of B here is minus a half lambda. The coefficient of A here is just 1. Okay, so let's look at the A's first. Let's look at the coefficients of A. So here we've got 2 lambda equals 1 plus K. Okay, those are the coefficients, okay, of A. Now let's look at the B's. Well, we've got minus a half lambda equals minus 1 plus K. Okay, now just rearrange this a little bit to get to make lambda the subject. And because the lambdas match up, this is a simultaneous equation, so you can plug this into that to get that. Just expand and then rearrange to get 3k equals, and that 3 equals 5k, so k equals 3 over 5. Okay, so which one was our k? So k was c2x. We don't want c2x, we want f2x. So we need to find lambda, because if you remember, lambda was our f2x. So just plug it into any one of the equations to get the other one. So k equals 5 over 3. K equals 3 over 5. I plugged it into this one. This one actually, sorry. And then we can solve for lambda. You get lambda equals 4 over 5. So in that 4/5 of this full line is f2x, because we wanted it as a fraction, and it's not far-fetched to say that 4/5 of this full line is f2x, because f2x is pretty big. So if f to x is 4/5, that means x to m is 1/5. Okay, because they both add up to one whole line. So they are in the ratio 4 over 5 to 1 over 5. Multiply both sides by 5. That's in the form you want, and that means n equals 4. Forgot to animate that, but it's fine. So P is the midpoint of FD. Okay, Q is the midpoint of DE. FD equals A. Okay, and FE equals B. Okay, well, we know that this is B, and we can say that F to P is half of A, because if P is the midpoint and FD is just A, that means half of it is half A. Similarly here, it's also half A. Okay, so, and we want to prove that PQ is parallel to FE. Okay, they look parallel, so that's kind of just make sure you're reading the actual right letters. Okay, so P to Q. We already know what F to E is. We know it's B. So P to Q. Well, to get from P to Q, we can go this way and then this way. Okay, we know that. Well, we don't know what D to Q is, but we can figure it out, because if Q is the midpoint, that means DQ is a half of this full line. Okay, so let's figure out what DE is. Oh, that should say D. Okay, so I'm going this way actually. So I'm going down here, then here, then here. Okay, so ED, this should say ED. So that's minus B, because we're going in the opposite direction, plus a half A plus half A. So it's minus B plus A. Okay, and then EQ will be half of it. So that's minus a half B plus a half A. So from P to Q, well, we can get minus a half A plus B, and then add this. And then that'll give us half B if you simplify it. And if you notice, well, PQ is a half B and FE is B. There's just a scalar multiple of a half. And whenever you have a scalar multiple between two vectors, they are parallel, basically. And I'll just quickly explain what the coefficients actually mean. But the coefficients are just the magnitude or the length of the line. So PQ has a length of a half units. We don't know what the units are, but it has a length of a half. And what the A's and B's mean, you can kind of think of it as the direction. Okay, so here the length here is a half, and the direction is A. Here the length is a half, and the direction is A. Here the length is 1, and the direction is B. Okay, and that'll be useful for the challenge question at the end. Okay, so O to X is A, and O to Y. Where's O to Y? O to Y is B. P is the point on OX, such that O to P, P to X is 1 to 2. Okay, well, if this is 1 to 2, that means this full line adds up to 3. And this takes up one part of it, and this takes up 2 parts of it. So if the full line is 3, and this takes up 1, that means this is going to be 1/3 of the full line. And this is going to be 2/3 of the full line. Similarly here, for r, if O to y, r to y is 1 to 3, that means the full line has a length of 4, and this is one part of it, and then this is 3 parts of it. So 1/4 of the full, so 1/4, because we get the 4 at the bottom of the on the denominator because it's just the full line. So 1/4 to 3/4. Okay. And if this full length is x, we can say this is a third. If the full length is a, sorry, we can say that this is a third a. This is 2/3 a, because it's 1 over 1 plus 2, and then 2 over 1 plus 2. Here we've just said this is. Oh no, we've not figured that out yet. Okay, so we know that z to y is also a because these are parallel, and well, they're just the same if you know parallelograms properties. Okay, then we can figure what we're looking for: z to p, z to r. So we're looking at this full line to this small line. Okay, we can figure out z to p because we can go this way, and then this way. Okay, O to y is b, so we'll go minus b. Oh, we'll put in the quarter. So 1/4, 3/4, because 1 over 1 plus 3, and then 3 over 1 plus 3. And then, so from z to p, well, we can go a minus b plus a third a. And then, I've gone for z to r first. So yeah, a minus 3/4 b. And then z to p is a minus b plus a third a. Okay, and then just put this in a ratio. I've simplified that first, then put it in a ratio. And then just simplify normally. So multiply both sides by 4, I think is what I did. Is that what I did? No, I added b. Okay, so I added b to both sides, and then you can multiply by 4, I think. I am multiplied by 3, it seems. Yep. To get a to 3 over 4b, and then multiply by 4. And then, yeah, so the ratio is just 4 to 3. Because it's 4 parts to 3 parts. It doesn't matter what these numbers are. I guess you could include it, but as long as you know that the lengths, because this is looking for the lengths, not particularly the direction, so you can just say 4 to 3. OAB is a triangle. OAB. OPM is OPM and APM, straight lines. M is the midpoint of AB. Okay. O to A is A, and then O to B is B. Okay, and then O to P, P to M is 3 to 2. So O to P, P to M. Similarly here, if this full line is 5 parts, because 3 plus 2 is 5 parts, then this is 3/5 parts. This is 2/5 parts. Okay, O to M. Well, we can figure out O to M, because we need to figure out first how to get from O to A and then A to M. We know O to A, so how do you get from A to M? Well, A to M is a half of A to B, and A to B is minus A plus B. Okay, that's just to show how to get from O to P. Ignore that. Okay, so yeah, so just listen to what I'm saying because this slide I made like quite a while ago. So anyways, from A to B is minus A plus B, and then we want a half of that because we want to go from A to M. So a half of minus A plus B, which is here. Add the A to go up here. So we've added this and then this. That's what this on the inside is. And we want to go 3/5 of it. So we want to go 3/5 is this line here. That's O to P. Okay, so we have this full line as A plus a half minus A plus B. So this here in the brackets, in the inner brackets, is O to M. And then O to P is 3/5 of it, because we figured it out as 3/5. Because it was 3 to 2, so 3/5 to 2/5. Expand that to get O to P is 3 over 10A plus 3 over 10B. Okay, oh yeah, I forgot to say, but we're working out O and B, so this to this. Okay, and the reason why figuring out O to P is useful is because we can figure out 2 different paths from O to N. Because remember, whenever you have a question with a ratio, you want to find 2 paths to any one of them. I've just gone with O to N. So from O to N, well, we can go this way and then this way. Or we can go this way and then this way. Or you can go this way. Okay, so we figured out O to P because we can say O to P plus P to N gives us O to N. Okay, O to N is OA plus AN, and we can say that ON is also K lots of B. So if this full line is b, there's then some fraction of this full line. Remember, we're using fraction again. So some fraction of this full line gives us to n. Okay, and we've said that fraction is k. Okay, that's one way that we've gotten from to n. Okay, to n is also what is it? A plus an. We know that a is a, and then an. Well, an is it's not too tricky to figure out, because if we know a to p, and we know a to p, because if we know that a to p is 3 over 10a plus 3 over 10b, then we can figure out a to p. And I'll tell you why that's useful. So a to p is minus a plus this. Okay, so it's like minus 7 over 10 plus 3 over 10b. Okay, and if we have ap, and we can say that some number multiplied by ap gives us a to n, because it's this line multiplied by some amount will give us an. Okay, just think about that for a second. So this length multiplied by a certain amount will give us this full length. We call that lambda. You can call it whatever you want. Anyways, yep. So we can figure out AP, because I've just said minus a plus AP. That's this. Expand to get this, and then plug this into there, and then you've got the lambda, so that's a to n. So we've got a to n, so we can go a to n. So that's a plus all this to get. Oh, I've just expanded this a to n. Plug that into there, so a plus all that, and that's our second way from a to n. Because remember, we have this, set these equal to each other because they're both the same, and then we're going to equate coefficients again. So looking at the coefficients of a, looking at the coefficients of b. So on the a's, on this side, we have 0 equals 1 minus 7 over 10 lambda. Okay, I've just put it on another slide. So we have 0 equals 1 minus 7 over 10 lambda. So 7 over 10 lambda equals 1, so lambda equals 10 over 7. Okay, now let's look at the b's. So we have k equals 3 over 10 lambda. We know what lambda is, plug that into there. So that's 30 over 70, or 3 over 7. Okay, and that makes sense, because we said if this full line, to b, if we take some amount of it, k, we'll get to n. So we're saying 3/7 of this full line is to n. Okay, so if this is 3/7, then this is 4/7. So the ratio is, I'll just put that there. So to n is 3/7 b. That means n to b is 4/7 b. So the ratio is 3/7 to 4/7 b's. And then cancel the b's, multiply by 7, and the ratio is 3 to 4. There is another way to do this question using mass points. I probably won't make a video on it because it's, not many people know what it is anyways, and I don't think you'd get credit for using it at GCSE because it's more of a competition thing. Anyways, OABC is a parallelogram. O to A is A, O to C is C. M is the point on BC such that BM MC is 3 to 2. Okay, so BM MC. Well, we know that O to A is A. That means B to C is minus A, because these are equal. Okay, and we're going in the opposite direction, so it's minus. Oh no, I've not done that. Anyways, yeah. So if C to M or M to C is in the ratio is 2 parts, and this full line is 5 parts, that means this is going to be 2/5. Okay, and this is 3/5 because it's 3 over 3 plus 2, and then this is 2 over 3 plus 2. Okay, so the line AB is extended to the point N. OMN is a straight line. Find ABBN. This is also C, by the way, because it's parallelogram, as the question tells us. And AB and ABBN. Okay, so we want to find 2 different ways to get from A to N. Okay, well, if we can figure out what A to N is, well, and we already know what A to B is, we can work out B to N. And then we'll have ABBN. And if you remember, this is very similar to literally the first question. So we'll figure out what A to N is. Well, A to N, we can go down here and then up here. Or we can just go some amount up here. Okay, so CB is A, So, and an, what have I said here? An is some amount of c. So this, if this is c, then this length 10 multiplied by some amount gets us a to n. So imagine this line here, AB, where 1 is the length, like we've said. If we multiply that by some amount, the length is going to extend to a to n, from a to n. Okay? And we've called that c, that scalar multiple. Now we need to find a different way from a to n. So we consider that a to n is c plus 2/5 a. And I'll tell you why this is useful, is because, well, if we know what a to m is, we can figure out what a to n is, because it's just going to be this line multiplied by some scalar multiple, which we can call lambda. Okay? And we can figure out then what a to n is, because we can go down here and then up here. Okay? So a to n is some scalar multiple multiplied by this. So this line here, which we know is c plus 2/5 a, imagine you extended it out by a factor of lambda to n. So a to n is that, and then a to n is down here and then up that. And that's our second way. So we've got two ways. We can make them equal to each other. Expand. Here, what are we doing? So we're looking at the a's. We've got 0 equals minus 1 plus 2/5 lambda. Rearrange. So 1 equals 2/5 lambda, so lambda equals 5/2. And if you just look at this, well, this makes sense, because if a to m is c plus 2/5 a, then a to n is some amount multiplied by that. And if it's multiplied by an amount that's greater than 1, in this case it's 2.5, then the line will extend outwards. Okay, so this line, if we had this line 2.5 times, we'd get a to n. That's what we're saying. Okay, now let's look at the c's. So we have k equals lambda. Okay, so that means lambda and k are the same, so that means k is also 5/2. So a to b and multiplied by 5/2 gives us a to n. Okay, so a to n is 5/2 c. Okay, because I've just plugged this into there. If this full line is 5/2 c, and we know what a to b is, we can work out b to n. Because it's this full line, take away this small line. Okay, so 5/2 c take away c is 3/2 c. So if this is 3/2 c, 3/2, that should say c, not a. If that's 3/2 c, and this is c, so the ratio is c to 3/2 c. C's cancel. We want in the form k to n, so multiply by 2, divide by 3. So that means k is 2/3. It's actually kind of my fault. I shouldn't have made my other variable k if the question's already got it in k. But it doesn't matter, because you know what I mean, because I'm explaining it. OAD is a triangle. OA is A. OD is A plus D. C is the point on the line AD, such that AC AD is 2 to 3. Okay, so AC AD is 2 to 3. Okay, that's interesting. I'm sure, I feel like some people would make an error here, so they might think it's this line to this line, but it's this line to this full line. Okay, so we can say that AD is minus A plus D. Okay, and we can say that AC is 2/5 of D, because we know that AD is D. So 2/5 of D gets us from A to C, sorry. Okay, and OCB is a straight line such that OCCB is 3 to 5. Okay, so for O to C is going to be 3/8 of this full line. Okay, because it's 3/3 plus 5. If this full line is 8 parts, and then this is 3 parts, so it's 3/8. Okay, you can also work out this one, because if that's 2/5, that's 3/5, obviously. You can use this if you want, or you can just notice that they must add up to 1 whole part. And OC is 3/8 of this full line OB. We can work out what OB is later. Okay, and we don't know what CB is. We just know that it's going to be 5/8 of OB. Okay, and the vector AB is lambda A plus mu D. Okay, so AB is lambda A plus mu D. And OC is, so OC going this way is A plus D minus 3/5 D. Okay? And now if we're saying this equals 3/8 of OB. Okay, so OC equals 3/8 of OB. Multiply both sides by 8, divide by 3. To get OB is this. So this full line is 8/3A plus 16/15D. And then we can work out what CD is that what I'm going to do. Because I think I'm going to do this full line, take away OC, which is here, to get CB. Yep, that's what I've done. Simplify that. So CB is this. Now we can get from A to B, because we can go this way, then this way, because we know what CB is now. So just do that. And then expand. So we're saying that AB is in the form lambda A plus mu D. So the lambda must equal 5/3, because that's the coefficient of A. And the mu must equal 16/15, because that's the coefficient of D. So it's 5/3 to 16/15. And that simplifies to 25 to 16. But AB is a triangle. Oh yeah, and also I've tried to include every type of vectors question that they could ask you. So if you remember, one of them was about proving that two lines are parallel. Another one is finding the ratio of a full line, and if it was like say split at any point. And the third type that they could ask you is proving that something is a straight line, showing that something is a straight line. And the way to do that, I'll just go through it and I'll explain it as I'm doing it. Okay, so OAB is a triangle. P is the point on OA. So it's that OPPA is 2 to 1. So if the full line is 3 parts, this is 2/3 parts, 2/3 of the full line. This is 1/3 of the full line. Okay, so 2/3 of 6, because OA is 6, gives us 4. Then 1/3 of 6 gives us 2. Okay, so that's 4A, 2A. And remember, OA is 6A, so question tells us. And then we know that OB is 4B. We're also told that M is the midpoint. Okay, and M is the midpoint of line AB. Okay, and what else have I done? Does it tell us information about OC? C is the point, such that B is the midpoint. Okay, so if B is the midpoint, that means this part must equal this part. And just think about it, because if this full line is 8B, and then half of it is 4B, that means the full line must be 8B. Okay, so if I have an amount of the full line, and I do a half of that, I'll get 4B. So if I have 2 halves, which adds up to 1, will give us, so 2 halves, if 1 half is 4, 2 halves is going to be 8. So that means the full line is 8, so this is 4 as well. So these, this is equal to this. Okay, so we want to get from P to M. Well, we know that we can get from A to M, or M to B, or BM, MA. But let's just figure out A to M. Because we can say that AB is minus 6A plus 4B. Okay? And then AM is going to be half of that. So minus 3A plus 2B. So PM is 2A plus this. So plus minus 3A plus 2B. To get, and then this is also a half. This is the same amount. Because if M is the midpoint, then this equals this. So P to M is, what I've just said. Let's simplify that to get that. Now we want to find out what M to C is, because the line is PMC. So M to C, that's minus 3A plus 2B plus 4B. Simplify that to get that. And look, so you can say that because there's a scalar multiple, here it's 3, and because they share the common point M, it's a straight line. Okay, so that's all you need. So whenever you're showing that something is a straight line using vectors, you'd say that there's a scalar multiple of whatever, and that they share the common point, whatever. So here it's PMMC, so they share the common point M. That means it's a straight line. Okay, and if you think about that, well, it makes sense, because on a straight line, if say PMC was a straight line, which it is, PM is obviously going to be parallel to MC. And if this is parallel to that, that means there's a scalar multiple. Okay, but just having a scalar multiple isn't enough, because we could have the line here for PM, and then we could have MC. Well, we could have the rest of the line down here. Okay, and that doesn't help us because that's not a straight line. Obviously, it's in two different parts. But if they share the common point, that means they must be right next to each other in a straight line. So that's how you show that. This question, I actually took this from a what is it? So it's a year 12 paper. No, it's a year 12 Edexcel textbook for pure maths 1. And yeah, it's in the vectors chapter. I think it's chapter 12 maybe. I'm not too sure. So although this is an AS level question, it's not too far fetched that you'd get something like this at GCSE, because the questions before that you've seen, some of them are I think all of them are GCSE if I remember correctly, and those are harder than this one, or around the same difficulty level. Okay, so we're told that OA, remember OABC is a square, so that means this equals that, which equals that, which equals that. So OA is A, and OC is C. Now the reason why you can't say A equals C is because remember A and C represent directions. The coefficients are the same though, so 1A equals 1C, so 1 equals 1, but that doesn't help us, so we can just forget about that. So O to A is A, M is the midpoint, so that means OM is a half A. Forget about that. So that's half A, and then that's also half A. OC is just C. Same with here, it's also C. And then here, it'd also be A, because it's a square. Okay, APC and MPQ are straight lines. Show that P divides AC in the ratio 2 to 3. Okay, so it divides AC. So if this is 2 parts, this is 3 parts, and the full line is 5 parts, then 2/5 is AP, and then 3/5 is PC. Okay, so we want to find the ratio of AP to PC. That's what this question is telling us. So how do we get from A to P? 2 different ways to A to P, remember? Well, so we can go this way, then this way, and then this way. Or we can go this way and then this way. Okay, BQ to QC is 1 to 3. So BQ, if the full line is 4 parts, it's 1 plus 3 is 4. And this is 1 part, so it's 1 over 4. And then this is 3 over 4. And it's minus because if this full line is A going up, then this is going to be the same, but we're going in the opposite direction, so it's a minus A. Okay, so that means we can figure out what AP is, because we can go this way, then this way, and then this way. Okay, so AC. Oh no, so what I've gone for first is AC. So AC is C minus A, or minus A plus C. And we can say that AP is some amount of this full line. So remember, this full line, do a fraction of it, we'll call it K, and that will give us AP. Another way from A to P, like I've just said, well, we can go down this way and then this way. I actually didn't go this way and this way and this way. I've just gone this way and this way because that's quicker. So we can say that if MQ is a half A plus C minus a quarter A, because we've done this, add half C plus C minus a quarter A. Then MP is some amount of it, which we'll call lambda. And AP is minus half A plus whatever that is, MP. Because MP is some amount of this, which we've called lambda. So this here, after the plus, is MP, and then this part here is AM. Okay, these two equal the same thing, set them equal to each other, expand. Equate coefficients, look at the A's, so we have minus K equals minus a half plus a quarter lambda. Okay, and then looking at the C's, so we have K equals lambda. You can put K equals lambda into there. Just solve for that. So K equals 4 over 10 or 2/5, and lambda also equals 2/5. And we want AP to PC. So the one that we used, the variable that we used to represent AP of this full line, AC, was K. Okay, so we said that 2/5 of line AC, because we're looking at AC, is AP. So this is, if this is 2/5, then this is 3/5. Okay, so that's 2/5 to 3/5. Multiply both sides by 5, that's 2 to 3, like we want. Okay, I don't know how many more questions I have to go. Anyways, A is A, B is B, M and C and A and B. So M and C and A and B are straight lines. M is the point on the line OB such that M and B, and B is in the ratio 1 to 5. So the full line has 6 parts. This is 1 part, so 1, 6, 1, 6, 5, 6. Okay. N is the point on A and B, such that this is 3 to 2. Because the full line is 3 plus 2, so 5 parts. This is 3/5. This is 2/5. Okay. The reason why it's minus A plus B is because it's 3/5 of this line AB. And the line AB is minus A plus B. Okay. OB is parallel to AC. And this is important because the fact that they're parallel means that there's a scalar multiple between them. So if this is B, we can say that AC is K lots of B. Okay, so just remember, because they're parallel, there's a scalar multiple between them. And if there's a scalar multiple between them, they're parallel. So it's vice versa. So if this is B, then this is some amount K multiplied by B. Okay, and we can say that Mn, this is just another part of the question, so we can say that Mn is 5/6b, 5/6b, minus 2/5 minus A plus B, close bracket. Okay, and then and I've not expanded that yet. Anyways, so we've got M to N now. This is useful because we know that we can say that Mn multiplied by some scalar amount gets us N to C. It doesn't get us M to C, but it gets us N to C. It doesn't matter. It could get us M to C, but we've just randomly said ourselves we want it to get N to C. Okay, and that's lambda. Okay, so this full line, this line here, M to N, if we multiply by a certain amount, not enough to get the full line, but if we just multiply enough to get N to C, then we'll call that lambda, that scalar that's done that. Okay, so we have M to C as lambda, and now we can figure out OB to BC, because we can say that OB is B, and then AC is KB, OB to AC. Okay, yeah. And then we can also find another way from A to C, because we can go this way, then this way. Wait, no, we can go this way, then this way, because it's AC, not OC. So this way, and then this way. So it's 3/5 minus A plus B, close bracket, plus NC, gets us AC. Okay, and that's that. And these two are now the same, because here we're just solving for what this scalar multiple actually is, what K is. Set these equal to each other, expand. Looking at it is, so 0 equals minus 3/5 plus 2/5 lambda. Just rearrange solve for lambda. So lambda equals 3/2. And that makes sense because we've scaled this line up just enough to get NC. And then now we can solve for K because let's look at the B's now. So we have K equals 3/5 plus 13/10 lambda. Okay, we know what lambda is, so we'll just plug that into there. So K equals 5/4. And this also makes sense because if this full line is OB, then 4, so 5/4 of that full line, so 5/4 of OB gets us AC. Okay, that makes sense because we've scaled this up. They're still parallel, but one of them is just scaled up. So AC is 5/4b, sorry. Okay, so the ratio of OB to AC is B to 5/4b, because that's B. And cancel the B's, we want it in the form K to 1, so multiply by 4, divide by 5, so K equals 4/5. Okay, this is the challenge question. I really recommend that you just pause the video right now and you try it yourself. And then you might need to spend maybe 20 minutes. Take as long as you want. Even if you spend an hour on this question, really try your best at it, because even getting halfway into this question is a really big achievement, and you should be proud, because although you'd never be asked something like this at GCSE, being able to do as much of this question as possible shows that you've got a really good understanding of it. Okay, and I've taught you everything in this video leading up to now. As long as you've watched it all up to now, with that knowledge, you should be able to answer this question. And also, just some basic knowledge about octagons. Okay, that's a clue. So, stop the video now, have a go at the question, and then yeah. Okay. So that's your time. I'll go through it now. Okay, so we're saying that AB is A and BC is B. So that means this is A and this is B. Okay, so this is probably what everybody got to. Now, let's look at what the question is telling us. So X is the point inside the octagon such that AXG and HXE are straight lines. So AXG, HXE are straight lines. HXXE is in the ratio K to 1. So K to 1. Find the value of K. So we want to find two different paths from H to X. Like I've told you, always want to find two paths from H to X. So one way is that we can go this way, then this way, or we can just go some amount of this full line. Okay? So how do we even find this path here? So we'll go this way and this way first. So how do we even find this line here? Well, we can say that HC, we know it's a straight line. If you know something about the properties of octagons, we know that HC is a straight line. But we also know that it's parallel to AB. That means this is some scalar multiple of it, which we'll call T. Okay, and now we can find what H to A is, because it's TA minus B minus A. And similarly, we can say, well, if this is B, if GF is B, HE is lambda B. Okay, so we've just scaled it up by some scalar. Okay, yeah, so that. And we can say that HA is TA minus B minus A. Okay, and we can say that HX is some amount of this full line. The full line is HE, and we'll say that the scalar H that gets us from HE to HX, we'll say it's N. Okay, so N lambda B is H to X. Okay, AG, because if we can figure out what AG is, we can figure out what AX is, because it's just some amount of AG. So AG, well, that's AG is plus A plus B minus TA plus lambda B minus A minus B. Okay, and then simplify that. So AG is lambda B minus TA. And we can say that some amount of it gets us from AG to A to X. We'll call that amount M. Okay, and now we've got A to X, so we can go from H to A to X. So H to X is also that. And now these two are equal, so set them equal to each other. Now let's look at the A's, and then we'll look at the B's. So looking at the A's first, I've just expanded this. Looking at the A's, well, we've got 0 equals T minus MT, or T, same thing. And then here, looking at the B's, we've got N lambda equals minus 1 plus M lambda. Okay, and this actually isn't useful right now. It is really useful, but not for right now, because we don't actually have enough information to solve what these are. But if we can figure out what T is, or what lambda is, then we can solve this. And just one way that we can do that is, well, we can say, if you remember at the beginning, I said that the A's and B's and T's and whatever, sorry, not the A's and B's, so the coefficients of the A's and B's mean the length. Okay, so if we draw a triangle here, and we say let one side of the octagon be 1. Okay, we can pick whatever we want. I've just picked 1 because it's easy to work with. Okay, we'll say that AB is 1. That means BC is 1. This is 1. That's 1. Every length is equal in a regular octagon. Okay, so if that's 1, and then this is a right angled triangle, this is the same as this. These two lengths are the same. Okay, it's a nice isosceles triangle. So just use Pythagoras. I'll call this y and this y. So 2y squared equals 1. So y squared equals a half. So y equals 1 over root 2 or root 2 over 2 if you rationalise. So that's root 2 over 2. And then draw another triangle over here. Okay, and well, this length, h to whatever this is the same as this to this. So these are both y. Okay, and this is just 1, because if this is 1, then this is 1. We can say that h to c, the length of it, is 2y plus 1. Okay, so 2y plus 1 equals the length t, which we've said is t. Okay, so just solve for that. So t equals root 2 plus 1. Okay, so plug in t into there. Expand, simplify. So you get this, factor out the m, and then just divide by root 2 plus 1 to get m as this. And then I've rationalized it to get 2 minus root 2 equals m. Now let's just bring this onto another line. So we figured out what m is. We figured out what t is. Okay. Now how do we figured out what m is. So even if we plug in m into there, we still can't figure out what n is, because we need to find n, because remember h to x is the n scalar. Okay. If this is h to e, n amounts for the full line is h to x. So we want to find out n ultimately. Okay. And so the next step to do is just keep this in mind. So the same scale factor for octagons. So from here to here is the same scale factor from here to here. Now you might just know that property, and that might tell you, well, if t is root 2 plus 1, that means lambda is also root 2 plus 1. But if you don't know it, because I didn't originally know it when I first did the question, you can just prove it yourself. Because say if you drew a triangle here, so this leg here and this leg is equal to this leg and this leg. So this is y and y, and this is 1, because remember it's the sides of the octagon. So 1 plus y, and then 1 plus y, and then square this side, square that side, and that will equal lambda squared. Okay, so do that. I just use the calculator for this because you get a quadratic and it's just long. Is that a quadratic? No, it's not, but it's just long. So yeah, anyways, you solve this. So lambda equals this, or lambda equals that. And well, you have to say that, well, lambda can't equal this because this is a negative number. Okay, and the length isn't going to be a negative because you can't have a negative length. So you have to say that lambda equals root 2 plus 1. And that was obvious at first because we said that t was root 2 plus 1 because there's the same scale factor. Okay, so lambda is root 2 plus 1. Okay, and now we can just plug that into there. We know what m is, so we can plug m into there as well. So just do that, solve for n. N is this. Okay, now we've got what this amount is. So if this is n, if root 2 minus 1 over root 2 plus 1 is this amount, then this full line, which is lambda b, which is the same as saying root 2 plus 1b, take away this amount, which is this, will get us x to e, sorry. Okay, I've just rationalised that first of all to get n equals 3 minus 2 root 2. Okay, so if we know what h to e is, that's root 2 plus 1b, root 2 plus 1b. And now we know what h to x is, that's root 2 minus 1 over root 2 plus 1. So we can say that this full line, root 2 plus 1b, minus root 2 minus 1 over root 2 plus 1 will get us x to e. Okay, so do that. That should not say h to x. That should say x to e, I think. Yeah. Okay, so, wait, no, it's not. Oh, no, sorry. So what I've done is, because I've said that h to x is n lambda b, some amount of it. So we know that n is this, we know that lambda is that. So we're saying that h to x, because we've not solved for it yet actually, h to x is n multiplied by lambda multiplied by b. Okay, so I've put this into there. Solve. So h to x is root 2 minus 1. Okay, so this is root 2 minus 1. The full line is n is just a lambda b, sorry. So it's root 2 plus 1b. So root 2 plus 1b minus bracket root 2 minus 1 close bracket gets us x to e. So n lambda is that, but that's obvious. You don't even need to say this. So h to e is root 2 plus 1b because it's just lambda b, obviously. So this, take away this, gets us x to a. Okay, do that, xe therefore equals 2b. So the ratio of h to x to e is root 2 minus 1 to 2. Okay, but another way that you can do it is, I've just done this not really for any reason, but it's just a bit easier to do it this way, because h to x, hx to xe is the same as saying hx over xe. Okay, so if if you've done much work with ratios, you don't even need to have done much work with ratios, but the ratio a to b is the same as saying a divided by b. So we can say that hx divided by xe equals k over 1. K over 1 is just k. So hx divided by xe equals k. The reason why I've done it this way, which you'll see, is that, well, we know that hx is root 2 minus 1, and xe is 2. It would be a b, but the b's cancel. Okay, so we can say that k equals root 2 minus 1. And doing it this way is just much quicker than actually doing arithmetic, because you can just leave that as your answer. So k equals root 2 minus 1 over 2. One thing that I forgot to mention actually was, say in this step here, when I used n lambda, I actually unrationalized n, because if I did, then the root 2 plus 1's cancel. So lambda cancels with the denominator of n. That gives me hx. Okay, so I did rationalize it, but it turns out you didn't actually need to do that. That's just what I was doing when I was doing the question. So if you don't rationalize it, then this just cancels nicely with this, and that's just easier to work with. So yeah, k equals root 2 minus 1 over 2. Well done if you got that, because that was a very hard question. And you see, you never get a question like that, as I said. But yeah, if you can do it, that's great. Anyways, so that's all the questions done, and I've put here some practice questions for you. They might look very similar to the ones, the other ones, but the numbers are different, so it's not the same answer. So there's this. You can just pause the video and then have a go at them yourself. I'll post the answers in the comments at a later date. Not too long though. I won't take too long doing it. And here's the second one. Interesting use of this. To just make sure you're reading the question carefully. Rewatch this video or parts of it if you really need to, because this is a hard topic. Can't remember how many practice questions I did. There might be, I think there might be 10 or 12, but I could be wrong. This question it's quite a lot of information. So what I've tried to do is I've tried to pick what I believe to be the hardest questions, and then I went through those. The reason why I did that is because by doing that, I can show you guys as many different techniques as possible, and then you can employ them in these questions. Now, these questions are also difficult, but yeah. So I've left a couple quite difficult questions in this part. Nowhere near as difficult as that challenge question that I just showed you, but yeah. So they're just here so for the sake of putting together all the techniques that I've taught. If you remember, this is similar to question 3, I think, but the numbers are different. So yeah. Then there's this. This is also another similar question, but it's different. And that's the last question, yeah. So that's the last practice question. Remember, just pause at any one that you want to have a go at, and then I'll, like I said, I'll post the answers.